Hello, welcome back to my channel. This is Ethereum Protocol Studies, okay, where we take a concept related to the blockchain protocol and try our best to break it down and explain it for better understanding. Yeah. So my name is Fedor Emmanuel. I'm a blockchain enthusiast and also a protocol engineer in this space. Yeah. So today we'll be doing like a walkthrough, just not an in-depth walkthrough, but just a walkthrough the Go-Ethereum client, just to see how block validation happens, just to see some functions that are being called in block validation. Yeah. So last week we talked about block validation. We stated that block validation is a process whereby a block is being checked or verified that it complies to the consensus rules. Yeah. And basically to check some data and other metadata that are contained in a block. So we say that a block contains a list or a set of transactions that are to be executed. Not just set of transactions, it also contains the hash of the block before it. That is why it's called the blockchain. So it contains the hash of the block before it and some other metadata. Yeah. So today we are going to be doing a walkthrough in the Go Ethereum code base. Yeah, so with that being said, let's jump right in. So here there's a function inside of the ETH folder, a function called new payload. Yeah, new payload. So inside of this function, I have a function called new payload. Yeah, so this function takes in arguments and it returns, here it says it returns execution engine.payload status v1. Yeah, that's a struct that has a lot of fields in it, so and also an error. Yeah, so here this is a mutex, so say locks m. If the lock is already in use, the calling go routine blocks until the mutex is available. And, this is not that important to the context of what we're doing today. In the context of what we're doing today, it's not that important. So here it says log.trace engine API request received, block error engine executable executable data to block. So yeah, so in this function it says executable data to block, construct a block from the executable data. Yeah, so we're passing the parameters that was accepted by our new payload function here. Sorry about that. Here. Yeah, passing the parameters that was accepted here to this executable data to block. Then we check if there were any errors. Found the block got used. So this one function takes in a message string. In this case, in our case, is invalid new payload params, meaning that the payload is invalid, and more like this CTX is context. What it means, it takes in a variable number of any type. An empty interface means any type. So you can take in any type here. That's what we see here. This is going to return a number. Len is going to return an int. Here, this is going to return basically any type. So it takes in a variable length of any type here. So let's move forward. Here you see there's a function here that says get block hash. Get block hash. So here, function called get block hash. So this function gets the hash of the block. Yeah. So like we said when we were explaining block validation, we said it's kind of like when validating a block, the hash of the parent is checked, and also the hash of the block. So there's that. Get block hash function get block. Yeah. So let's go back to our code. Check this function says check invalid ancestor. So if this block was rejected previously, keep rejecting it. This contains the payload failure response. So what this function does, it checks if the block has been rejected. So this res is going to contain the payload failure response. I wrote this comment today, as you can see. So there's a lot happening in the new payload function. Yeah, so at this point, this is a method that returns a blockchain. So here, with that blockchain that was returned, we can call this insert block without set head method. Yes, in Golang we can call that. So it says insert block without set head, executes the block, runs the necessary verification upon it, and then passes the block and associates the associate state into the database. Okay. So if error is not equals to nil, log.1. So we're logging this message. Hash block.hash. Yeah, so let's look at this function. Yeah. So we've read about that. So inside of this function, we see that there's another function called insert chain. Let's look at it. So here it says insert chain is the internal implementation of insert chain, which assumes that chains are contiguous. Exactly. So inside here we have a lot of things going on. It says if the chain is terminating, don't even bother starting up. Yeah. So if the chain is going to be terminated, that means if it's not canonicalized, or if it's not the canonical chain, you should not bother starting it up. So come here, and there's a function called verify headers. Let's look at it. So verify headers, we know that when a block is being validated, there is I think there's a section of the block called the header that contains metadata like the parent hash and the timestamp and all of that. So verify headers, it's inside of an interface. So let's check out the implementation of it. I think it's here. Yeah, this is. Yeah, this is verify. This is the verify headers function. So verify headers is similar to verify header, but verifies a batch of headers concurrently. So yeah, this is the implementation. So here we have verify header. So says instead of verify header, verify header checks whether a header conforms to the consensus rules, like what we've been saying. to check if a block conforms to the consensus rules of the stock Ethereum consensus engine. Yeah, so this verify header could be called by a variable of type beacon. Yeah, so it kind of does some checkings. So here it says verify blocks difficulty to ensure the default constant, which is 0. The difficulty is expected to be 0 for beacon blocks. So here, to verify that it's actually a beacon block, the difficulty has to be 0. So that is what this check is for. And then here we say we verified that the gas limit is less than or equal to 2 raised to power 63 minus 1. Let's check that.